Well, good afternoon, everybody. My name is Troy Raska, and with me today is Dr. Rajiv Sahai, the Director of Environmental Diagnostics Laboratory at Pure Air Control Services, as well as Pure Air Control Services Chief Science Officer. Welcome, Dr. Sahai.
Thank you, Troy, and welcome to all of our participants. Today's topic is very interesting, so we'll proceed with that. Thank you.
Yeah, so today we are talking about an evidence-based approach to air purification units, or APU, or APUs for short. And so we know that this pandemic has heightened the awareness of a lot of these technologies, but still some folks are confused about the subtle differences between these types of technologies and how they are best used in a building. So today, hopefully, Dr. Sahai and myself are going to help clear some of these questions up and maybe even get more questions from you, our participants. So let's dive right in. So today we're going to be talking about very quickly indoor air quality and the importance of IAQ, just to sort of set the stage for why these types of technologies are needed and why they have been in many cases developed even long before the COVID-19 pandemic. And then we'll get started looking right at this very technology of air purification units. So we'll look at the various kinds of technology, what they're used for, and then finally we'll talk a little bit about how to best select the type of technology to use depending on your occupancy, building type, and other factors to help make an informed decision. So as you know, Pure Air Control Services and the ED Lab, we are focused on indoor air quality. It's been our primary area of focus for the last 36 years. And so, but before we dive right in, we have a lot of different types of people with us today, everybody from engineers and facility managers to people that are in the C-suite and maybe even purchasing or procurement. So we want to be able to define what indoor air quality is and how it affects buildings. So there are some subtle differences between indoor air quality and indoor environmental quality. And so indoor air quality refers to the air quality within and around buildings, especially as it relates to the comfort and health of the building occupants, whereas indoor environmental quality is a term that talks about the suitability of the built environment as it relates to the comfort, safety, and health of the occupants. So there's some subtle differences between them. And Dr. Sahai, would you like to add maybe what some of those differences are between IAQ and IEQ?
No, that's a very precise definition. That was really essential to give our audience sort of feel, because I'm pretty sure media and elsewhere they have very frequently coming across the word IAQ and IEQ. The one thing I want to emphasize that IEQ may be the subset of, like, a bigger picture of like what is the entire environment is. But since we are talking about the indoor environment, so it is specify mostly the occupiable buildings and occupiable space, etc. At the same time, the IAQ is a subset of IEQ, because your environment encompasses not only air but several other entities or components. So when we are very specific on the air, then it relates to the air quality, and that is very essential for a healthy living.
Yeah, that's very true. I mean, indoor air quality has been thrust into a white hot spotlight because of this COVID-19 pandemic, but firms like Pure Air Control Services and others have always realized that it's a very important constituent to building health and occupant health, especially
Yes.
in the in the age of airtight or energy efficient buildings as we've moved through the 80s, 90s, and early 2000s. And so now we have more buildings that are tight, and now more parameters affect the air quality within those buildings now more than ever. So when we look at the
Yes.
importance of indoor air quality, we can see that there's many different things that can affect the quality of the indoor air. And so Dr. Zahai, why don't you take us through this little chart here, this graphic, and explain how these things are interconnected.
Sure. But before I go in there, I just wanted to little clarify a term used by Troy is that airtight. Airtight is a term refers in modern days building where we have taken over the ventilation through the mechanical means. Earlier it used to be natural. Whosoever has seen in 50s and 60s, there was no legacy of centralized air condition on every building or more frequent or common buildings. So what was happening that the ventilation was sort of natural, that what you are getting from outdoor experience, you are going to get same thing exchanging the air and things like that. So that was nature has its own way of controlling everything. But due to the energy efficiency or the energy thing come in a picture, that become a big thing. So in modern buildings, what they're doing, they are controlling the ventilation through a mechanical system that can, the intent behind that is to not only provide an adequate working environment or safe environment, but at the same time people should feel comfortable. But if there is any breach in designing of that, that create a lot of problem. And that's why it is essential to understand this terminology is not very frequently used, energy tight or ventilation tight. These are the terminology used. So I wanted to clarify that. Now this is an important chart I want to share with our audience, that why it is important, why the IAQ or indoor air is important. The very first thing is that it is directly affecting the occupants' health and hygiene. You really do not want to be work in a condition which is not very hygienic, because there is two type of thing is going to happen. One is going to be psychic, that okay, I'm in a dirty environment, so I'm going to get some disease or some kind of infection, some kind of allergy. And nevertheless, it is nowadays COVID, because you want to have an environment which should be adequate and clean so that you don't compromise your health. Now, the CBR of enclosed environment, C stand for chemical, B for biological, R for radiological. So these are the major category of pollutant and contaminant. So if you are in a place which is having a compromised indoor air quality, then you will be facing that problem directly. Like I said earlier, that ventilation management is a big thing for energy tight building. So ventilation, how much adequate? ASHRAE 16.2 talks about it. So in a building, if you are by yourself or you are in a group of people, then the requirement of air for those occupants is really depends. So we cannot have a rationalize just all across the board. So it depends, and we will be talking about that a little bit more in our presentation. And of course, energy conservation, because we do not want to waste the energy, because we want to use the energy as efficient as we can. It is also said that energy saved is energy produced. So think about it. If you are saving 1 kilowatt an hour, you are actually generating 1 kilowatt an hour, because you are going to utilize or you are going to save that energy to someone else. And then productivity optimization, you have a lot of other things to worry beside indoor air quality. If you are worrying all day long, indoor air quality, indoor environment quality, your production go down. So this chart is telling that how the indoor air quality is being affected. So very first thing is the chemical substance around you, because wherever we are in occupiable environment, or at home or building or a facility or a workplace or a shopping mall, everywhere there are a lot of chemical is being used in the building material. So there is a possibility that those chemicals may be not very good for intervening in the natural way of building the stuff. The second one is the microorganisms and biologicals. There are several microorganisms, and I'm pretty sure every single everybody who is in this presentation understand that there is a buzzword going around is called as mold. So mold, bacteria, allergen, etc. This is the microbiological entity because you do not see with your naked eye, and that's why you need help. And that's why you organize them or you manage them, that how you are going to control those so that they cannot influence your indoor air quality. Occupancy and activities, like some of them are built environment used for commercial use, and under the commercial use it can be hospital, it can be office building, it can be several other type of building which we will be discussing a little later. And then type of occupancy, type of profession. So these all have an impact on the indoor air quality, and I will be explaining you how. And then of course indoor environment quality is obviously influenced by the environmental quality, which is, everybody understand what an environment is. The ecological, like, surroundings, they have a greater impact on the environmental issues, including temperature, humidity, and all those parameters. So that is sort of importance, and that's why it is very, very important to understand that in the era of COVID, how we can manage our air in a way that it should not make us sick, or it cannot make us think all day long that, oh my gosh, I'm in an environment which is not good, I'm going to get sick. So that is a symptom which we can be not worried about too much if we know the right management.
No, that's a very good point, Dr. Sahai. And as a matter of fact, if we think about living through this pandemic right now, and this very topic that we're talking about, air purification units or air cleaners, many folks have run right to these technologies thinking that it's going to solve all of their problems within the building. And in some cases, it's because they're a visual product that can go right on the wall or right in the room with the occupants. Other times, products like this are being sold as a whole building solution, which is just simply not the case many times. And so your initial chart that you were talking about is a very good way to visualize how all of these components affect a building. And likewise, that's why air purification units alone are not going to be the single source answer for any kind of issues facing the indoor environment or air quality within a building. That's why we look at it as a sort of holistic approach, where each of these categories affects the other. And so that's why it's important to have good air purification units and have a good knowledge of them, but that's just one piece of the puzzle. In fact, we recommend understanding what the baseline conditions that Dr. Sahai was just talking about, right? Understanding what those conditions are, bringing those into acceptable standards, and then looking at anything that we find in those types of investigations and taking corrective action to, again, bring that into alignment to acceptable quality. And that could be anything from the HVAC system that's operating at a deficiency to get it cleaned up, get it restored, the ductwork, which can spread a lot of particles, any sort of environmental hazards within the occupiable space that need to be disinfected, and disinfected at a higher level in many cases than the janitorial or housekeeping crew can do in the case of mold or other issues within the building. And then we look at putting air purifiers in. Once those baseline parameters have been investigated, mechanically addressed, and are brought into an acceptable state, then we can look at air purification units to help maintain, or as Dr. Sahai said, manage the indoor environment to keep it at an acceptable level. And of course, there's other options to continually monitor those conditions and get sent alerts should something go out of alignment. So that's why we say there's no silver bullet. Don't be thinking of this one category, air purification, as a silver bullet to fix all of your indoor air quality issues. So when we talk about air purification units, basically what we're saying is that these are just devices or technology that are designed to remove or eliminate contaminants from the ambient air within an occupied space to improve the air quality indoors. So it's a very basic definition at face value, and as you will see, and we'll move through, and Dr. Sahai will explain, there's very different kinds of technology that's used both in the room, within the mechanical systems, and perhaps even within like lighting ballasts and things like that. So we're going to, take a little bit deeper look now at what these technologies are. And so as this slide becomes sort of the outline for the rest of the presentation, we're going to look at filter media, adsorbent media, plasma and ionization, photocatalytic oxidation, electrostatic precipitation, and ultra-germicidal irradiation, or UVC, UVG. So these are the primary technologies used for air purification right now. They're recognized by the Environmental Protection Agency and other organizations as being sort of the industry standard categories for air purification. And as a matter of fact, if you go to the EPA website, they have a whole category about this with some pretty important downloads that go into great detail about each one of these air purification categories. So the first up and most common is filter media, or filters, which typically go right into the HVAC air handling unit, but are also found in many portable air scrubbers, as well as in-room or localized air purification units. So Dr. Sahai, how does this filter media really work?
Well, that's a very important question. In the filter media technology, what is intent here that cause a restriction, and I'm trying to take an approach so that everybody can understand. So I will be trying to not use the jargon. Sometimes it is very hard to narrate the exact word or terminology that fits, but I will be trying to give you the information in a very simple layman manner so that you can understand. So it's quite obvious that if you create a restriction and a pathway of something, that is going to stuck because it doesn't have a lot of space to get it released. So based on that technology, the filtration technology come in picture. And the filtration technology is one of the trustworthy technology, and it is in this industry, or this industry welcome this technology, and it is existing for a while, and still I do not see any reason that why it cannot be used, or it is not going to be obsolete in near future, as it is one of the very, very basic technology that typically used by air filtration system. So how it works? Well, as I said you that you cause restrictions so that you can capture the particle from its original path. So how you do it? You basically apply a mechanical force to get the air across, but at the same time, the restriction in terms of pore is not good enough or wide enough that all the particle is going to get across. But you are applying a mechanical force to get the air out. And a pure air doesn't contain a lot of debris or particles. So the air is going to easily penetrate and pass through that the media or the system which you have put in the path due to the mechanical pressure. And that's why it is important that how much mechanical force need to be applied to get the air going, but not other debris or sort of contaminant in that. And that what you call it the efficacy, and the efficacy is generally reported in terms of MERV, and I'm pretty sure the MERV you have seen in the home improvement stores such as Home Depot, Lowe's, and other store you go, and they will ask you to put the filter. They will ask you that what MERV rate you are looking for, or if you know that what MERV rate you are looking for, you are going and checking the brand. I'm not using any brand name, but I just cited some general how you go in a store and start looking for. Well, one thing I want to tell you, a lot of folks doesn't understand MERV, and neither a lot of company explain it, but MERV is nothing but it is a abbreviation for a word, minimum efficiency reporting value. And that is sort of a scaling system which varies from 1 to 16, 16 being the highest like rate you can achieve, and 1 being obviously the lowest you can achieve. And there is certain other parameter or other scaling system which also exists to rate the efficacy of a filter, and one of those scale is NBPI, which is microparticle performance rating, and FPR, filter performance rating. These are the scaling system people apply to find out or figure it out that this particular type of filter is adequate for that particular application or not. And that is being done by doing a lot of efficacy testing. We will be also talking about a little bit more on the efficacy testing, how it is being performed. But that is the goal, that is the scaling system, just to find out, figure it out, that which is going to be adequate. And of course, it is very important, as I said you, that the filtration system can be integrated with any other system, but it is going to be one of the base or primary system in a way that it is not going to let pass lot of contaminant and pollutants. And this is still, as I said you in the onset, that very widely used, and it is used not only in the air conditioning system, it is also used in the portable air purification unit. You will get a lot of example throughout this presentation. We will be explaining a little bit more that how it is being used singly or how it is being used in combination of some other technology.
Sure.
That makes sense?
Dr. Sahai, can you explain a little bit about the term HEPA filtration? And am I correct in thinking that basically it overlaps the MERV rating? It sits within a certain area of that MERV scale to be able to effectively filter particulate. Is that correct?
Yes, the HEPA is like, those kind of filter which is basically takes like, 0.3 micron particle or more take out. So you are going in the size detail, and that's why it is high efficiency filter. That is a short form for the HEPA, and that is being used. And as you understand, I was talking about the energy conservation. So everything is directly related with the energy. Like if you are having too much of HEPA filter in the line, or like in your air conditioning system, of course you will be able to filter most of the particle or many of the particle of that size range which I just referred. But at the same time, that is going to cost you more energy because you require more pressure, mechanical pressure, and that you can generate at the cost of energy. So that goes hand to hand. Like if our goal here is to figure it out that how the air purification unit works and how the air conditioning unit works, and how we can make a option or choice that can be happy with your budget and that can be happy with your health and hygiene. That's what we are going to accomplish during this presentation, to just
You're absolutely right. And I think that it's important to note that through this pandemic, and we've seen it firsthand, that there are a lot of facility managers or HVAC techs that just think that they can grab a higher efficiency rated filter and put it into an existing air handler. And that air handler, as Dr. Sahai said, requires mechanical force and static pressure to move the air to condition it. And so if those machines aren't designed, engineered for that rating of filter, you can damage that equipment very easily or affect the indoor environmental quality, because now what happens is, as Dr. Sahai said, filter media is restrictive. And so what's going to happen is the airflow or ventilation, which is so important during this pandemic, is going to be itself restricted. So you will have a harder time controlling temperature and humidity in the zones that HVAC system services. So we want to be very careful not to just think that you can put a higher rated filter in your air handler unit unless you check how that air handler unit or the controls are designed. So
Yeah,
while,
not
go ahead.
one thing I wanted to tell Troy that not all the time the HEPA is the right solution, and neither like higher MERV rated is right solution. As I said, the HEPA itself understands for the high efficiency particle of air. So if you are going to restrict and you are going to create more restriction, like you are explaining, of course you have to pay like more in the energy, and many a time your goal is not to restrict like particle less than like zero point 0.3 micron, because at the same time like we are worried about the COVID-19 and the SARS CoV-2. Everybody knows their size range is like one of the vital issue people or scientists are talking about, and that's why a whole lot more discussion in the HEPA and the MERV rating is in picture right now.
Yeah, that's correct. And then, moving from standard filter media, which is primarily designed to capture particulate matter, then we start to look at adsorbent media, right? And then this is pretty good for odors and VOCs and some other things. Is that correct, Doctor?
Yes, because absorbent media is one of the media which basically removes like inorganic and organic compounds.
Mm.
And if you remove organic and inorganic compound, basically you are managing the odor. Like the odor, it comes from various chemicals. So if you are removing the source, meaning the chemical, then you are not going to experience any kind of like odor for that. So what happened, how it is being done is that air which is containing both organic and inorganic compound very with the high porous structure, and that structure is bounded with an absorbent chemicals, in other words. So the chemical is going to absorb in that media which is being bounded or coated in that filter, and then apparently you are going to get the air across the filter free from that particular substance that may cause the odor. So this type of media is good if situation demands for some obnoxious or some kind of pungent odor which can make you, if not anything, uncomfortable, unpleasant, then this kind of treatment is basically recommended. So when like as I said you, the passing through this media take care of the pollutants and absorb all kind of chemicals as per the concentration and quantity of that absorption media which is being placed on the filter. So this is good for, in nutshell, for removing the odor and stuff. And one of the very widely and commonly used absorption media is loaded with activated charcoal. That is one of the wonder compound, you can say, that can absorb various kind of gases, compound. They are emitting the odor, things like that. It is being removed, and I said you that how it removes.
That's a very good description of how that absorbent media works. And so again, would you consider this a subset of filter media? It's just a certain type of filter media. Is that correct in thinking?
Yes, you're absolutely right, because as I said you that this particular type of media, as you can see, I can hover that there is an activated charcoal. So what it does, it bound the compound with like the carbon or carbon activated compound that get soak, in other words, in that particular media. But at the same time, if our goal is to prevent certain size of the particle or contaminant or the contaminating agent, then we have to be also using this filter in conjunction with some other filtration device that can take care of that particular size range. So again, one solution doesn't fit in everything. That's why our goal is to inform you that what is your need, and if you recognize your need, then we have an evidence-based suggestion that it work in that particular situation or that particular environment, and that's what we are trying to achieve during this presentation.
Great. So as we move from filter media, we'll start to talk about other technologies that have come into play during this pandemic and in many cases before, but are being discussed even more. And one of those is called plasma or ionization. And then, of course, later in this presentation, we'll also talk about bipolar ionization. But in its very basic form, Dr. Sahai, why don't we explain to our audience what plasma and ionization is?
Well, that's a very important, and it's very important to define it. Plasma is a state of matter. Like everybody can see, like, solid, gas, liquid. This is the three very common state of matter, but there is another state of matter is called as plasma, which is go beyond that, meaning it is going to be beyond your sometime visible range, because you do not really see the plasma state of many material. So what it composed of? It is composed of something called as ion. Something is positively charged, something is negatively charged. If it is a positively charged, you call it cation, and if it is a negatively charged, it's called as anion, like you can see here. So how you achieve this, and why we do this kind of technology, and why people start thinking about this technology that can be helpful in the air purification? Because it has a very, very basic character that positively charged molecules are attracted towards the negatively charged molecule, and vice versa. So what people has done and think, in the plasma technology, they have generated the plasma, meaning a state of thing, by doing, like, discharge, like electric discharge in a tube, like you can see here. And that how, when you have negatively charged pole and positively charged pole and the electric discharge, then the ions is being created, anions and cations. So what is happened, these are the very highly penetrative molecules, so they start binding themselves in the existing molecules which is in surrounding. So some of them are going to get positively charged because they are going to gain certain electron or certain, like, proton. So they are going to be charged in one or the other way. And then if you have a very strong force, like lot of negatively charged molecules are around, and if you generate like positively charged, plate, then all the molecule is going to set on that plate, and that's how you are going to imply that one in the indoor air quality, because all the charged molecules are going to drop down on that plate which is charged opposite to the contaminant, and then finally it is going to get removed, and then it is naturalized. Sometimes the negative and positive kind of cross to each other, and they kind of neutralize and cancel each other, and then finally whatever the residual, it is going to be that environment, that what we can easily remove by, again, filtration, because you can filter them out. Does that make sense?
Yeah, it does. And I think what we're looking at, again, in its basic form with plasma or ionization on this slide, is a cathode tube, right? So this is sometimes maybe considered tube ionization, and these tubes can be put into clusters to create various intensities or release of the ions, and depending again on what application that you're going to put this technology into. So we have seen this type of tube technology placed directly in ductwork, like in the airflow stream, or inside air handler units to be able to help disinfect the equipment or the ductwork. Typically, we saw these first enter the marketplace in two ways, and one of them was in printing presses, so printing shops to eliminate static electricity, because the old way of printing involved metallic plates, and so there was a lot of issues with static electricity because of charged particles in the air, and this effectively removed them. And then another early adaptation of this was in food processing. In food processing plants, to keep bacteria low, or eliminate bacteria on the processing lines. And so one thing you have to watch out for, Dr. Sahai, if I'm not mistaken, is that in these kind of clusters of cathode tubes, ozone can be a byproduct of some of these, let's call them industrial applications. Is that correct?
Yes, like you said, and I said, it is a very high state of matter. So in air, we know that we have a lot of oxygen also, right? So it can kind of penetrate the oxygen, create the nascent molecule of oxygen, and then oxygen nascent molecule are very reactive and they can bind together to create the ozone. So yes, ozone can be the resultant. Therefore, it is recommended that the use of the ionization technology should be under a strict protocol, and the dosing and everything need to be determined, because ozone sometimes is dangerous for the health, and we have a direct impact of ozone. Ozone is also known as cancerous as well. So we should be, as long as we are using the technology in a controlled manner, everything under moderation is said good. But if you have a lot of ozone coming around your environment, so you are going to save, but actually you are not saving, you are deteriorating the environment. So that one of the thing, and Troy, you said very good point, because that how people start thinking about this plasma or ionization technique in air quality or air purification device or technology.
Yeah, Dr. Sahai, we've had a question, and I figured that once we got into talking about ionization, we would have a few questions, and I'd like to just answer them while we're talking about it. So we have a question from Katya Auer, who's one of our guests today, and it was a two-part question. And one is, what are the testing standards for these ionization devices, or maybe perhaps for ozone, right? We know California has a pretty high standard for what ozone has to be at. And then the other question was, and I think we started to answer some of this, is what are the side effects of this kind of product, which is how we got into talking about ozone. So what kind of testing or maybe certifications are there for these type of devices?
Well, there are certain standard ozone, and it is governed by UL under laboratory. So one standard call for 0.05 ppm of ozone. And again, I want to be very specific that these are not in generalized, and some of time this kind of a standard is in that case specific. Okay, so you should not be considering that this is uniform application of the standard, because you just talk about the UL standard that has also called for zero emission of ozone, like 0.005, and I said you in general 0.05. These are the two very practically useful standard. The lower standard, which is 0.005, is for the medical device and things like that. However, there is another standard is being floated that there is no ozone, meaning zero, like 0 ppm is acceptable for, especially like in a medical field or in the hospital and stuff. So people are looking for those kind of air purification unit which doesn't produce any ozone whatsoever. But so far the health base, that's what I said in the beginning, that you cannot take this standard and just apply across the board. But the health based standard really not only depend on the scaling system, but it also goes to the immunity of a person, or how susceptible or how reactive a person is in terms of the ozone concentration. So there are two basic units at this time about this, and it is governed by UL.
Yeah, and I also think that it bears mentioning that organizations, at least in the United States, like OSHA, Occupational Safety and Health, right, and NIOSH, both have limits, right, thresholds set for exposure to this and other kinds of VOCs at a certain level for a certain amount of time. And so if you really wanted to dig into that, I would probably start with OSHA or NIOSH to look at what they are saying is acceptable for exposure to, particularly ozone we're talking about here. But as we know, with the free radicals being introduced into this environment, different states of chemicals, different states of matter will change and then change again as they're hit with more of the negative or positively charged ions. So Dr. Zahai, I believe in your own studies, and you've seen VOCs go up and then down again, and then maybe up and then down again. So it becomes on a descending curve as they're hit with these ions. Is that correct as well?
Yes, yes, because the ozone, we have an opportunity to test several air purification device. As I said you that there is a number of components, still we are trying to exactly understand the mode of operandi, but so far, as I explained you that the highly reactive or penetrative ions are going to react with the oxygen, and the oxygen is going to break down in the nascent oxygen. Then they are going to be excited state, and they are going to form like, three molecules of oxygen bind together, and that become ozone. So that depends upon the availability of the oxygen in the air and how much charged molecule you have. That is one of the explanation, that it depend on the number of molecule available and reactive molecule available, and then at the same time the what kind of air availability is around that air purification device that can kind of lead to production of ozone. So it kind of go like that. So that's why the concentration of ions are one of the important parameter, and the availability of the oxygen and in the air is the another important parameter in order to understand this whole equation.
Great. Thank you for the question, Katya, and thanks for the explanation, Dr. Sahai. That was very good. Well, let's keep it moving. We want to talk about a few other different types of air purification units or technologies, and another one is called photocatalytic oxidation. And so in some ways this is similar to ionization, but it looks to be pretty different in some other areas. Is that right, Dr. Sahai?
Yes, because the ozone, I said, the ionization, I said you that there is a discharge, and it is going to be producing a plasma state of material that become like ozone. This technology is a little bit different because in the it is a light sensitive first of all technology, because it has to do photo. You see that technology start with the photocatalytic oxidation. So what happened, this is a very good diagram to explain this, that you have a light source which is the photons, or the produce light element, just say like that in the simple way, and then there is some kind of the metallic reaction. What it does, it oxidizes that metal such as titanium dioxide, and as a result of that you get a hydroxyl molecule get produced, and this hydroxyl molecule gets around the contaminants or around the target. Maybe it is a living cell or living molecule of bacteria and things like that, or living particle of bacteria, and that should be appropriate to say, that it kind of attach with that and then start lysing, like it start doing the effect to the bacterial cell wall, and it start getting the lysis. And as you understand that the bacterial cell or any other microbial substance or harmful bacteria, allergen, etc., start releasing its basic component, which is the H2O, meaning water, carbon dioxide, and other gases. So this technology important because this technology doesn't give you a lot of environmental residual. At the same time, it is going to destroy the target by producing this hydroxyl molecule because of the strong oxidation reaction, and that's why it is called as photocatalytic oxidation. And the oxidations typically happen in presence of, as I said, the metal oxide used as a semiconductor, such as titanium dioxide. I given you one of the example, and that is very important in terms of removing both biological, and I again underscore, this technology is very, very important, and it can help you in removing or limiting the microbiological contaminant or pollutant, as well as chemical pollutant or contaminant from the indoor environment or indoor air. Did that make sense?
Yes, it does, Dr. Sahai. And as long as I've worked in the field, which is about 6 years now, I haven't heard much about this technology, being used in a lot of the buildings that we're in. But I do know it exists, and folks are looking at it as one of many different kinds of air purification units. Another one that's very similar, again, in concept anyways, with the positive and negatively charged plates that are metal plates, is electrostatic precipitation, or ESP. And so, Dr. Sahai, maybe you can explain this as well, and maybe some of the situations that this is used in.
Yes, this is a very, very interesting technology. At this time, it is not very widely used, but it is being used quite a bit around the globe. In this technology, what happened, you create two opposite pole, like a negatively charged and positively charged. So the negatively charged pole are always looking for positively charged molecules to go in the equilibrium, because everything tried to be in the equilibrium. At the same token, many of the biological or abiological contaminant is charged one or the other way. So if you have biological particles such as bacteria, many a time you will see that the bacteria is slightly negatively charged. So if that bacteria come across a plate which is positively charged, it is going to attach or going to attract by that plate, and it is going to deposit it on that, and that way it is going to remove from the air extreme. So that these plates are indicative of that these are the negatively charged rods here and positively charged plates here, and then this air is going through. So what it is happening, the negatively charged contaminant or pollutants is migrating towards the positively charged plate, and positively charged contaminants are migrating towards the negatively charged rod. And what it does, it collect all those particles, because we use often metallic component for that. So they kind of settle on that, and that way it is being removed from the air stream. So this technique can be used where office building, or a little office, or the even sometime in a hospitals, like in a way that it's very useful, because it is not going to take a lot of space. It can be put in an air purification device in a slick design way, rightly engineered, so that the air is going continuously passing through it. And this is important, that this technique is going to remove all the particulate which I just explained, and that is the process called as precipitation, because it is going to precipitate, it is going to settle down, it is going to remove from the current air.
Well, thank you, Dr. Sahai. Again, that's one I wasn't so familiar with, but I do know it's out there, and of course, we'll probably see some of this technology being, as you said, streamlined and engineered in ways that we hadn't thought before, that maybe this pandemic and certainly our future buildings will be demanding. Of course, this brings us to the last couple of APUs that we're going to discuss on today's presentation. And we would be remiss if we didn't touch upon UVC, or ultra germicidal irradiation. This form of air purification or air cleaning obviously is one of the more predominant technologies in use, and has been for a while. Everyone from ASHRAE to the CDC recognizes its use, as long as you're using it in a safe and, as you said, correctly engineered manner. And so, Doc, why don't you just take us through this a little bit for those that might not know how it works. What is UVC, and what are some of the common applications here?
Yes, this is very interesting, and since we are also running with the time, so I will be summarize as much as I, but I'm always open to discuss. If you need any more information, you can contact me or shoot an email to Troy. We can explain. Well, real quick here, the ultra germicidal irradiation is a technology in which the photon is generated by doing the photochemical dissociation, and there is a particular wavelength. The wavelength is 100 to 1000 nanometer. Especially we have noticed that the wavelength between 4 to 600 nanometer is very important, that the wavelength 100 to 1000 work, but like really like 4 to 600 wavelength, this is sort of like in general terminology the power. So if you are developing that kind of photons, then what it does, it basically put the excited state of the matter, and when it goes in the excited state, jumping from the low to high energy status, and then excited electron can break the chemical bound, thereby altering the physical and chemical property of molecules and basically deteriorating them, or basically the lysis happen. So if you use this technology, you are directly attacking the physiology of a microbe, and that's why this is a very important technology, especially for cleaning bacteria, viruses, mold, and other allergens, especially the biological. So this is like very important. Next slide. I guess we have
Well,
to.
yeah, I mean, I think that when we look at UVC, we're seeing many applications of it. One, you have to be careful. You can't look at the UV light. The UV light, just like if you were sun tanning or going on a tanning bed, can cause burns. So you have to be very careful with the kind of devices that this is put into. But you can see it everywhere, from inside of air handler units and ductwork to what's called upper air UV, to lighting ballasts that has, again, a mechanical force, a fan that will bring air into the lighting ballast, pass it through a UV field, and then drop it back out into the environment. So when evaluating any of these kind of UV devices, again, you want to look at their UL ratings. You want to make sure that the design is good and engineered well, so that it's not going to cause problems for the occupants, especially UV products that are used within the occupied space. Again, I think we covered a lot of this, Dr. Sahai, when we talked about plasma or ionization in general. And so the viewers here can take a look again at how ionization works. But why don't we just briefly talk about the difference between bipolar ionization, which I think sometimes is referred to as cold plasma, and how that differs from charging a cathode tube and releasing the ions that way.
Yes, as I said, we are running on time, but still I will try to grab as much as I can. The bipolar ionization, that the name itself suggests, that in terms of bipolar ionization, that both negative and positive molecules are being produced. And then I have explained you in the ionization that these negative and positive molecules are very high energy bond compounds, so they are going to penetrate the molecule and then sort of agglomerated and conglomerated, that effect it start creating. And then once this thing is kind of neutralized, you can see in this photographs, then they are going to form like a bigger molecule. So a smaller molecule is going to be conglomerated to make a bigger molecule, and then it is being removed by filtering. So if your goal is to filter both, and this is, by the way, work both for the biological as well as abiological contaminants, so that once you have that group of molecules put together and become a bigger molecule, then you can easily filter it out utilizing various kind of filter. So that, in nutshell, that technology work like that. Now you can pack this technology by doing the engineering solution in combination of other technology which we have talked about. So it really depends that what is your goal, and next few slide I will explain you that what is important, what you should be considering to take care before you start selecting your APU, and that is very important. So very first and important thing is that the target contaminant. What is your goal? What you are trying to remove? Whether it is you are dealing with the regular allergen, you are dealing with the dust problem, meaning PM2 particles, or you are dealing with some kind of obnoxious gas, carbon dioxide, volatile organic compound, formaldehyde, etc., or you are having a source information that it is going to be a biological entity. So based on that, you can select one of the technology which we have already discussed, but like Troy was saying, that do not consider one technology as a magic bullet to get it finished, because sometimes technology require a combination of technology to address various kind of problem. You can do lot of technology combination to take care of more than one parameter at same time. Then what are the criteria you should be using, like a building criteria, like type of use of facility. Maybe like it is a drug manufacturing facility where you cannot tolerate like any kind of contaminant, because you are going to produce the contaminated drug. That is a very, very essential commodity. So you have to see that that building qualify for the best available technology, so that you can, I'm not saying that you cannot have a clean building for anything else application, but this require extra attention put in that way. Now you have a slaughterhouse. In the slaughterhouse, how the air is being managed there, and continuously lot of different kind of gases and things like that is emitting. So there is a different application. Office building where a bunch of computer engineers are working, that you have a different scenario. School building, hospital building, you name it. We will be explaining this in the next few slides. And then obviously the performance of the building, how the building is performing, what is the ventilation, it is mechanically ventilated or it is naturally ventilated, and occupancy, who is occupying this building. It is a occupational occupancy is commercial type or it is a residential type. So we will be explaining those in the next few slides. As I said, the target contaminant you can develop in this chart, that whether you are dealing with the abiotic or biotic. If you are doing the abiotic, in the abiotic sense, are you dealing with the chemical or you are dealing with the particulate such as PM2.5 or PM10, because PM2.5 particles are very small particle and it is going to end up in your lungs. So your intention is to control that. Then you can put HEPA filter and whatever we have talked, the filtration media, that is going to be the best media to use to remove those from the air stream. Likewise, other side you have a biological or the biotic component. So whether it is a microbes, you are dealing with the microbes, or any other plant or animal borne material such as plant trichomes, plant hairs, they can be also problematic. You can be get exposed and you can be allergenic on that. Now, the next slide I'm going to show you is about the type of building and use of building. So, Troy, we have seen this thing over and over, that the requirement for the occupational building is a little bit different than the residential building, and one can experience that. How they are going to experience? Because if you are thinking about the occupational building, the commercial place such as mall or a strip mall or some kind of a standalone, so there is how the air is being managed there. This is maybe a very huge area, big mall, like each day thousands and thousands of people are going in and out. So what kind of air we need in that condition? Now the healthcare encompasses of nursing home, hospital, assisted living facility, where a lot of people are not having a vigorous immunity or immune system. So you have to be very, very cognizant of what they are inhaling or what they are exposing. So you need to choose the air purification system or the unit in that way that it can be take care of those things. Institutional, like nowadays it's a COVID, so a lot of people are saying mask no mask, mask no mask. We are just discussing that, but the right approach would be to see that what kind of air quality we are exposed to. So we should be focusing on that, what kind of air quality we needed, whether this air encompasses or air is having any viral molecule. If there is a viral molecule, how we are going to clean it. So we can think in that. So far residential is concerned, whether you are living in a multi family residential building where the one air handler unit is serving several units, so that there is a problem in one unit or one condominium complex, for an example, then it is going to be fed by the other neighboring condo if it is being saved by the same air conditioning unit. At the same time, the single family home, that you are just like having the pollutant coming directly from the air handler, or it is like a result of from the inside or outside exchange. So these are the some type of building that also help you to think that what kind of air purification unit is good for you. Now, the next thing, the building performance. As I said, the ventilation is natural or ventilation is mechanical control. What is the airflow rate? Typically, in our offices or your house or residential area, like 4 to 5 air exchange. But if you go in a hospital or other facility where the air need to be like really circulated many times, so that you can thin out the contaminant or accumulation of those, that it can go up to 8, 9, 10 times. It's called as AHU, air exchange rate per hour. That what we need to maintain on that one. Then the air handler unit is the lungs of a building. So you have to be also thinking that what kind of air handler unit you have. Does this air handler unit come with its own filtration system? Is there any additional method is applied in that air handler unit in terms of UV, in terms of bipolar ionizer, in terms of ionizer, that what kind of provision is being made there, so that you can make sure that this is adequate. If you require additional help with the air handler unit in terms of air purification, then you can get some of the portable unit that can additionally help in the air which we all breathe, or our ambient air, because air handler unit is propelling the air, but at the same time it is not taking care of all the contaminant. Then we need additional help. Building envelope, that whether it is having a breach, it is going to be inside outside breach, or it is good, so we have to be taking care of that. And the possible source, whether it is a indoor source or the source is located outside, so that also depend what kind of contaminant we are dealing with. Many a time the biological contaminant is a result of outside, because outside you have a thick vegetation and there is a lot of mold is growing, and you have a breach in your conditioning, then it is coming. So your goal would be to remove those mold spore. So you will be looking for an unit which is not only remove the mold spore, but it would be better that it is going to deactivate it. So you will be we were suggesting different technology, so you can suggest that.
Yeah, I think the important thing to remember here, much like what we had at the beginning of the presentation, and which is why Dr. Sahai and I set this graphic up as a honeycomb, is to show that these parameters interact with each other, and depending upon how they are interacting with each other is going to help influence your choice in what kind of equipment, air purification units, that you would use for the building. It's also why it's so important to understand how the building's functioning and take care of any underlying issues that the building or the equipment has before you install aftermarket technologies and products into this building's system. So I think that it's very important to consider how these things all interact with each other as you are choosing the type of technology that you want to put in your building. I also think that, and Dr. Sahai and I discussed this a little bit, the types of occupants that come in and out of the space are also an influential factor. Not only the building type, how it's performing, but how the occupants themselves are actually interacting with this environment. And as you see here in this slide, it's almost like a set of gears, right? You have a daily occupant that is employed in a building, that works in a building all day long. You have frequent visitors that come to a building and maybe the same building, but they don't stay there for any great amount of time. And then you have what might be called transients, or people that might just visit this space one time. And so the actual environmental conditions of the building are going to affect each of these types of occupants in different ways. I liken it to a grocery store, right? You have someone that might just be in the area and needs to run in and get something very quick, and that might be a transient visitor. They might never come back to that grocery store. Then you have people that go to that grocery store 1 or 2 times a week. They're always in that environment a few times during the week. And then you have the people that work in the grocery store. So that building, that store affects these 3 types of occupants in very different ways because they're exposed to that environment for varying lengths of time that differ from each other. Is there anything you would want to add to that, Dr. Sahai?
No, that's you pretty much cover that. Like it also depend, like, if you are talking about the occupant, believe me or not, is itself is a bigger source or the vehicle for bringing the, pollutant or contaminant, because we just visit place to place, and that's the main theme here. We want to depict that, like, the source is being brought by a daily occupant, which is sort of like, each day, every day, it's right there, maybe business, maybe for resident, but sometimes some transient is going to bring flyby, like, get infected with something, and then he is going to, or she is going to blame the building. But many a time the transient people can also bring the contaminant in that building, because they come one time and then they never come back, but whatever they said, that going to stay in the building and going to compromise the building. So that's what the main focus here, to tell that, like, it goes both way. Next
Yeah, I
slide,
mean,
please.
like you said, for example, it could be someone infected with the cold or flu. It could be someone that has pet dander on them, and they come to the clerk at the bank and their pet dander goes everywhere, and it could create an allergic reaction with the employees of the bank. So, yeah, no, I
Yeah,
understand
and
what
then
you're
the
saying.
COVID
That's a
itself,
very
like,
good point.
if you are like, COVID infected, all you need to do, like, touch one time, and that's what a fantastic example, that you just go there as a transient, like, you are at a gas station, just pump the gas, but you have just make several other people who are going to use the same gas station. If there is a COVID or the SARS CoV-2 inoculum set there, then it is going to be transferred to the other. So these are some good example of, like, the how the occupancy, like, influence, and how the occupancy can be one of the crucial factor while selecting the, the air purification device. This is regarding the environmental laboratory. What we do here, our laboratory does a lot of microbiology and aerobiology kind of testing here, that include but not limited to allergens, bacteria, mold, and several other chemical and biologicals, including environmental SARS-CoV-2. And this laboratory is ISO 17025:2017 compliant. The one more thing I want to tell in this presentation is that, like, air purification device, we also pay a lot of attention, lot of detail by testing their efficacy, that I was keep in, like, emphasizing throughout the presentation, that it should be need based, like, what is your goal, what you are trying to remove, but some sort of assurance you need to have under the laboratory condition, that how an air purification unit perform in terms of its efficacy. You simulate various kind of condition, and you put those kind of air purification unit, and you see the efficacy, whether it is good for removing in allergen, bacteria, fungi or mold, particulate, volatile organic compound, formaldehyde, carbon dioxide, you can name it. So that can give you some additional ease. Once you have the laboratory testing, then you will be knowing that this is being done. Now, one thing I want to warn you, because some of the air purification unit company just take, like, a cubic foot of, box space, and then they perform the experiment and they say, okay, this unit is working. But in the true sense, that you should be simulating, like, office or home like environment, and then you try and test the efficacy of the equipment. That would be the real test, and that would be telling you that under the real situation or under the live situation, this is going to work or not. And that will tells you a lot, while you are while you are going to pick one air purification unit, and how you are going to consider one which is going to be more effective in a cost effective manner. That kind of test we perform here ED lab. We can also do a lot of testing for the ionizers, bipolar ionizer, and UV light, etc. So we have test all, so that some of the equipments are performing great, some of the equipments are not performing that great. We let their manufacturer know for the engineering revision, and many of them has reviewed their engineering, and then we consider the same equipment is testing good or performing good under the efficacy testing. So that is one thing I just wanted to tell you, that the efficacy testing is another parameter which you should be integrating while you are selecting the air purification unit.
Yeah, I think that that's a very good point, Dr. Sahai, and that is kind of bringing us to the conclusion of today's presentation. We thank everyone for hanging in there with us, and we have a few more questions, but I do want to make one point about the test chamber and our efficacy testing. One is that Pure Air Control Services Incorporated and the Environmental Diagnostic Laboratory, we do not make products of any kind. We are a professional services organization, right? So we go about testing and correcting issues in buildings, and in the case of our efficacy chamber, we are a third-party, independent, accredited laboratory that can test these types of products. That being said, we have other divisions in this company. As I said, our building sciences division that does testing within the built environment. Right, we have our environmental diagnostics laboratory, which takes those samples collected from building sciences and other third-party industrial hygiene and building engineers. They'll send their samples to our lab and we'll test them. We have a remediation department that will go into the building and decontaminate it, clean the air handling systems up. And then we have a separate sister company that does handle products. And while they make a few of their own products, they distribute quite a number of other products. I want to be very clear with this, and that is we will test on our own these products before we want to carry them. So what we're going to do is we're going to test against manufacturer claims or other laboratory certifications to make sure that that product is doing what it says it's going to do. And so any product we distribute will have been double checked and experimented with in our own test chamber. That being said, it brings us to one of the questions that we have, and that is from Peter Ruitt. And he's asking again about ionization or bipolar ionization. It says, are the ozone byproduct levels generated from BPI certified by the manufacturers? And so that kind of goes into what I was just explaining. I was kind of preemptively answering this question perhaps, but I would say yes and no. I would say that most manufacturers are not certifying their own products, but rather having independent laboratories like ED Lab and other laboratories, for better or worse, many in China, are certifying these products and putting them together with certain standards, like we referenced UL. So they're testing against those standards and then certifying them. So I would say while the manufacturers pay to have this done, they themselves are not the ones certifying. Is that an accurate way to describe that process, Dr. Sahai?
Yes, because there is two things. One is called as certification, other is called as verification. The certification is the actual standard. You take it and you kind of monitor that whether it is going to release oxygen or not based on their release ozone or not based on their technology. But at the same time, the verification, once it is being certified, then you can verify it that whatever the equipment is saying it actually performing or not. Like suppose you are claiming that your equipment or your device is 0.05 ppm or less, so somebody need to verify it come out of the factory and then it is performing as it intended to. So there is two things, let it be very clear. One is the certification, other is the verification.
Okay, thank you, Dr. Sahai. That was an actual, really good answer to follow up my novice, answer. But anyways, well, listen, it looks like there's no more questions. We ran a little bit over time, but we feel like this is a very important topic. As Dr. Sahai alluded to earlier, here's our contact information. At any time, if you would have a question about any of these kind of technologies, any environmental or air quality questions about your building, feel free to reach out to us, and we will certainly respond in kind, either with an email or even a phone call, because this is what we do. We want to help you help your buildings, and through that, create a safe place for your occupants. So on behalf of myself and Dr. Sahai, we thank you for participating today. There'll be a short survey as you're exiting the workshop, and stay tuned for our next workshop.
Yeah, thank you very much. Likewise, and as I said you that ozone is also a burning topic. Maybe we can consider those topics. We are always open for a topic which you are interested in. You can always shoot us an email, and we will try to disseminate information based on that. As throughout this presentation, we talk about the ozone level, ozone concentration. I said you that some of the equipment required zero ozone emission, and that is again the UL standard. If you refer the UL standard, you will find out that there are 3 or 4 different standard. 2998, I guess, is the standard which call for the zero emission. With that, I really appreciate your patience. We ran a little bit over time, but it was well worth time to understanding that while you are selecting your next air purification unit. Have healthy air, have good air. Thank you.
Thank you, everyone.